Welcome to The Explainer. Today, we're going to pull back the curtain on the invisible architecture that, well, pretty much runs our entire world, computer networks. I mean, have you ever really stopped to think about it? How does a message you send instantly travel across the globe? Let's get into the magic that makes it all possible.
All right, so let's start at square one. What is a computer network, really?
At its heart, it's actually super simple. It's just a bunch of computers and devices that are linked up so they can talk to each other and share stuff. That's it. Kind of like a digital group chat for your hardware.
Think about it like this. At home, you probably have one printer for the whole family, right? You don't all need your own. That simple idea, sharing resources, is exactly why networks are so powerful. It saves a ton of time, a ton of money, and honestly, it's the bedrock of our entire connected world.
Okay, so if a network is just a group of connected devices, how are they actually arranged? It's not just some random jumble of wires, right? There's a plan.
And that plan, that layout, has a name. It's called a network topology. I love this quote that describes it as a floor plan for a house, showing how all the rooms, or in our case, devices, are connected. And this is where things get really interesting, because you can see the classic trade-offs network engineers are always juggling. You've got the bus topology. Super simple, cheap, everything's on one main line. But, and it's a big but, if that main cable fails, the whole network is toast. Then there's the star topology. This is probably what you have at home, with everything connected to a central hub, your Wi-Fi router. It's great because if one device's connection fails, everyone else is fine. But if that central router goes down, yep, the entire network is offline. Finally, you have the mesh. This is the big one. It's the backbone of the internet itself. Devices are all interconnected with tons of different paths. It's way more expensive and complex, but it is incredibly resilient. If one path fails, no big deal. The data just finds another way. There's no single point of failure.
So we've got the blueprint, the map of the network. But how does your information actually get from point A to point B? Let's follow the journey.
Believe it or not, every single time you send an email or vote a web page, this lightning-fast 5-step dance happens. First, a connection is made. Then, the devices agree on the rules, the language they're going to speak. Your data gets broken down into these little chunks. Then, routers direct those chunks to where they need to go. And finally, the destination confirms they've arrived safely. It sounds like a lot, but it happens in milliseconds. It's like perfectly organized chaos.
So, about those little chunks, they're called packets. Instead of trying to send one huge file all at once, which would totally clog the pipes, the network chops it up into these small, manageable packets. It's way more efficient. Think of it like sending a long letter as a series of postcards, instead of one giant, unwieldy scroll.
And the devices that direct those packets? Those are routers. Honestly, routers are the unsung heroes of the internet. They're like traffic cops for your data, making split-second decisions about the best, fastest path for each little packet to take, steering them around digital traffic jams to get them where they're going.
Okay, but how do all these different devices know how to talk to each other? Well, that's where protocols come in. A protocol is just a set of rules. It's like grammar for computers. Without them, it would be total digital anarchy. You see them all the time. When you see HTTP in your browser's address bar, that's a protocol. It's the specific set of rules your browser and the website server have agreed to use to communicate. It makes sure everyone is speaking the exact same language.
All right, so we've gone deep into the mechanics. Now let's zoom back out and see how this stuff actually shows up in our everyday lives. The thing is, we're surrounded by networks of all different sizes, and they all play by these same basic rules. When you connect your phone to a Bluetooth speaker, that's a tiny little personal area network, a PAN. Your Wi-Fi at home, connecting your computer, your TV, all that stuff, that's a local area network, a LAN. And then when you use the internet to connect to, well, anything outside your house, you're tapping into the biggest one of all, a wide area network, a WAN.
And that's really the key takeaway here. From a simple home setup to the entire global internet, it all boils down to the same fundamental idea: connecting devices so they can share things and talk to each other. It's an incredibly elegant concept that just scales up and up and up.
And that leaves us with a pretty big question to chew on. As our world gets more and more connected, what happens when these networks fail? Understanding these basic building blocks isn't just for tech geeks anymore. It's the first step to really grasping the huge questions about our shared digital future.